Yeah, good evening everyone. Today again I am there in front of you with the part 2 of the villages, and hope you remember that yesterday when we were covering that I have covered what are the villages, what are the properties of the villages, and how properties are measured, and how that properties changes with the raw materials change. All these things I covered yesterday. Now today, then I spoke that the next part 2, I will be covering the role of the raw materials in the villages. Each and every raw material in the village is very important. So that is number one. Number two, then during firing, if oxygen is less, then also village behaves differently. If oxygen is more, then village behaves differently. So depending on oxygen, signing of the village changes. So now I will come to the point. Suppose barium carbonate which in the village during firing gives barium oxide, and that barium oxide when we mix in the village, the barium carbonate we mix in the village, that gives the hardness in the village. It improves the hardness of the surface. And if it is very less quantity, then glossiness of the wear of that glaze improves. If we put barium carbonate in suppose more than 6-7%, then it gives matte surface of the glaze, which we call matte glaze. Somewhere I will be talking later on, covering that what types of glazes are there. So the types of glazes, so it gives matte glaze. And then barium carbonate, I said it improves hardness, then it means it improves wear resistance of the wear. Then it improves chemical resistance. Sorry, it reduces chemical resistance. Then it will, when we add barium carbonate to the glaze, then it will reduce the melting point of the glaze also. Then we have to do trial and error at what temperature we need the glaze. So trial and error, that percentage of the barium carbonate we decide, and each plant can work out the percentage for their raw materials and for their temperature. Then in glaze sometimes we see the cloudy effects. Barium carbonate helps in reducing the cloudy effects on the surface of the glaze. So that is next point. Next raw material we cover soda. It means sodium carbonate. Then sodium carbonate it will improve the glossiness of the glaze. It improves the thermal expansion of the glaze. And if we put more sodium carbonate, it develops crazing in the glaze, and then this thing it improves that, it causes means low flow, means better flow of the glaze, and because of this better flow, that glaze will flow on the surface of the wear at that particular temperature, and then it helps to reduce the pinholes on the surface of the wear. So that is the major role of the sodium carbonate, soda ash. And when we talk about calcium carbonate also, like suppose it is a flux, calcium carbonate directly reacts to silica present in the glaze when glass formation takes place, and it helps the strong interfacing of the glaze with the body. And when it improves the interfacing, means bonding of the glaze and body, then it reduces the chances of crazing. This raw material, calcium carbonate, calcite, also help in improving the hardness of the glaze. If we put same thing, if we put more percentage of the calcite, then it also gives the matte effect. So matte glaze. Okay. Now only drawback with this material is that calcium carbonate, when during firing, then it releases the carbon dioxide, and there are the chances during firing that because of this carbon dioxide, pinholes on the surface may increase. So that is the drawback of this thing. If suppose it improves, it decreases the solubility of the lead in the glaze. That is the role of this calcium carbonate. And when we go to zinc oxide is a calcium carbonate is flux. Zinc oxide is a very strong flux. It gives we say that glaze is brilliant, means shining glaze. So it increases the shining of the glaze. All these glaze raw materials, up to certain percentage, it helps in shining, hardness, flow, everything. Beyond certain percentages, which I already said that each plant has to work out for their raw materials compositions. So here also, if suppose in percentage of the zinc oxide is more, then matte glaze effect comes. Zinc oxide, if we add, it increases the flow of the glaze. When it flow of the glaze increases, then it increases when it is flowing, it increases the surface tension of the glaze. And this low thermal expansion is the contribution of this zinc oxide to the glaze. Okay, now cratering effect because of zinc oxide sometimes and most of the times gets solved. If suppose zinc oxide we are adding, if it is more and that glaze shrinkage is high, thermal expansion is high, then glaze may crown on the surface of the wear, so it gives crowning defect. All this, and we talk in refractive that spinels. This zinc oxide develops the spinels, different like refractive spinels. It develops special surfaces and colors on the surface. So that is the role of zinc oxide. We talk about that. Suppose we talk about that potash feldspar, soda feldspar. So we talk about potash feldspar particularly for the glaze, and potash feldspar and soda feldspar means potash and soda both give same kind of effects, but this potash feldspar, if we increase the percentage of the potash feldspar, then there are chances of cratering defect. Potash feldspar is preferred for these glazes. Potash feldspar, because of this potash K2O, it reduces the pinholes on the surface, whereas in soda feldspar there are chances of getting more pinholes. Sometimes our manufacturers they take that soda feldspar. Someone will supply that it is potash feldspar, but it will be soda feldspar, and they use it like potash feldspar, and they faces the problem of more pinholes on the products. So that is the role of this thing. Generally nowadays we don't use lead biesilicate or lead oxide. All this thing, lead oxide also is like zinc oxide. It is a strong flux, Lead oxide, if we use that, we generally, most of the people, they use in decorative ceramics, art ceramics, studio ceramics. They use this kind of glaze. The wares where we use for our table wares, for hotel use, for our kitchen use, we will not have any glaze based on lead, because lead is poisonous for our body. So lead also, when we use lead carbonate, also reduces viscosity. It reduces the surface tension of the glaze. It will reduce the hardness of the glaze. It will reduce chemical resistance of the glaze. All these things are not required for art wares. Lead oxide, as being the low temperature of the glaze, low temperature of the material, so it sometimes it evaporates easily. Okay, and when we add copper oxide in the glaze, okay, and we are using lead based glaze, so then lead will get easily released and it is dangerous for wares. Is now, if we use very small amount, as we say that up to 2 ppm lead is allowed in wares. So if we use very small amount of the lead oxide, then glaze surface is very smooth. Now next raw material I will cover what is the magnesium oxide, magnesium carbonate. So it also produces high surface tension in the glaze. It gives low thermal expansion to the glaze. So suppose low thermal expansion, body thermal expansion, and this thing. If body thermal expansion is high, then we have to select the right raw material to increase the thermal expansion of the glaze. If now this raw material, magnesium oxide, is suitable if the thermal expansion of the glaze is low, like corderite based cookwares or something, we want to do the glaze, then those wares are of that low thermal expansion and magnesium oxide. So corderite itself is based, MgO is the part of the corderite. So this helps in that type of glaze. If we add that magnesium oxide very low quantity, means then it helps the glossiness it provides. And is suppose we increase the amount of the percentage of the magnesium oxide, then it will again give the matte effect. So till now you have learnt, if we up to certain percentage, all these oxides will help to improve the glossiness of the glaze, hardness of the glaze, flow of the glaze, reduce pinholes in the glaze. So if we up above some percentage, then all the glazes will become matte effect. Alumina is another part which we add to the glaze. So alumina, as you know, that 2050 is the melting point of the alumina, and if we add directly alumina, although we get through some feldspar, this thing, glaze, means not free alumina. So alumina is the very hard raw material, having almost 9 on the Mohs scale, sorry, hardness. So it will, so as the raw material indicates, if alumina goes to the glaze, it will increase the hardness of the glaze. It will reduce the, because density is high, alumina density is almost 3.9, so it will again, then it will reduce the flow of the glaze, because it is heavy raw material. And alumina will help in forming the crystals in the glaze. It will reduce the thermal expansion of the glaze. And same thing, if we add more alumina, then it will have the matte surface. Now, zirconium oxide. Zirconium oxide is the most important raw material which we get through zirconium silicate or this thing. So, zirconia, which is known as opacifier, it is an opacifier and very important raw material for the glaze. So, when zirconium oxide, if we take it, that it should be very fine. More means, if, for example, if it is 100 minus 100 mass, opacity may be less. If it is minus 300 mass, opacity will be further better than this 100 mass based. So opacity increases as the particle size of the zirconium oxide reduces. Hardness will increase because it is high density raw material. Flow will decrease because it is high density raw material. Surface tension, because it will not flow so easily, so surface tension of the glaze will increase. So, and when surface tension of the glaze is there, glaze will not flow easily. There are chances of getting the pinholes. But zirconia plus point is that it reduces the cratering effect. But we cannot avoid zirconium silicate in the glaze. Means ZrO2, SiO2. So very important raw material. Now silica also, some we don't get it in free form, which also is a, because glaze is a glassy surface flowing on the surface of the wear. Silica plays major role to form the glass, so it is a glass former. Then it is this thermal expansion, that is silica thermal expansion is higher side. It reduces cratering in the glaze when, and then it reduces the flow of the glaze because 2.6 is the density of this thing also, but better than zirconia and this thing alumina. Silica, when with this thing it is there, then it will have acid resistance. Silica helps because wares may take thermal shock, so it will have weather resistance. And hardness, it will increase because of silica, but not more than that alumina and zirconia. Then there is another very means low temperature, low melting point like 300, 350. That B2O3 is there. B2O3 borate, which helps in forming the borate glass. So it will lower the melting point of. We add this thing to the glaze. It will lower the melting point of the glaze. It will have low thermal expansion. Then it will reduce the cratering of the glaze. It will means because it is low temperature, so it will increase the maturing temperature range of the glaze. Suppose we say that we are 1260, so 1260, some glazes may be 1250 to 1270, it will mature. So like that, that range will increase, and then throughout the 20 degree, 30 degree range, it will give good effect because of B2O3. So, suppose some crystallization, some cratering is taking place, then it will help to reduce that effect in the glazes. So, I think most of the raw materials which are very important for the glaze I have covered, and this thing, then maybe in my next lecture I will be talking about types of the glazes, then glazes for suppose high temperature glazes, then I will be talking about that some other unique raw materials, what are the role of those unique raw materials, what are fritted glaze, what are non-fritted glaze, what are raw glaze, what are you can say lead less glazed, what are lead glazes, then raw glazes for studio potteries, so and chemical based glazes, and totally raw chemicals based glazes, not that raw means I will talk that suppose iron oxide from the mines, chromium mines, manganese mines, iron ore mines, we get so many raw materials which gives very good effect for the glazes. And this thing, and only thing is you cannot repeat the consistency of the glazes for so many wears. So it is common. It is you cannot have the quality consistency by glaze point of view. So each wear will have different effect, and sometimes this kind of effects are liked by means artists and for their architects. Then so many people they like for their drawing halls. They put different unique pieces, so everything will be unique. So nature has given us wonderful raw materials for using in ceramic in different ways. That is our smartness how to use that. So I think on this village I am done, and if you like this thing all that, please keep on listening and keep on waiting for my next lecture, which will be on different topics, and I am going to start some topics which will be totally your personality development skills. Technical skills are one side, managerial skills and personality development skills plays major role to make you perfect technical person. With this I am done. Thank you very much for listening me. Bye bye.